Electric cars are on the rise. They offer a cleaner alternative to gasoline vehicles. At the core of every electric car is its battery. This battery stores energy. It powers the car's motor, providing the energy to move. These batteries are complex and fascinating. Understanding their creation offers insights into transportation's future. They are a step towards sustainable transportation, crucial as we move away from fossil fuels. Key to reducing oil dependence. Demand for electric cars drives battery innovation, leading to more efficient, longer-lasting batteries, essential for widespread electric vehicle adoption. Electric car batteries are made from a variety of raw materials. These materials are carefully selected for their electrochemical properties. They are extracted from the earth and then refined. Lithium, a light and reactive metal, is a key ingredient. It plays a crucial role in the battery's ability to store and release energy. Cobalt, another important material, helps to enhance the battery's performance. Nickel and manganese are also used in some electric car batteries. These metals contribute to the battery's stability and capacity. Graphite, a form of carbon, is used to create the battery's electrodes. The extraction and processing of these raw materials can have environmental impacts. It is important to ensure that these processes are conducted responsibly. Sustainable sourcing of materials is crucial for the ethical production of electric car batteries. The process of making electric car batteries starts with the creation of individual cells. These cells are meticulously crafted in high-tech facilities where precision and quality control are paramount. These cells are the fundamental units of the battery. Each cell is designed to store and release energy efficiently, ensuring the overall performance of the battery pack. They are where the electrochemical reactions take place. These reactions are crucial for the battery's ability to charge and discharge, providing power to the electric vehicle. Lithium-ion batteries, the most common type used in electric cars, consist of two electrodes. These electrodes are carefully engineered to maximize energy density and longevity. These electrodes are separated by a layer of electrolyte. The electrolyte is a critical component that facilitates the movement of lithium ions between the electrodes. The electrolyte allows lithium ions to flow between the electrodes. This flow is essential for the battery's operation, enabling it to store and release energy as needed. The cathode, one of the electrodes, is typically made from lithium, cobalt, nickel, and manganese. These materials are chosen for their ability to store large amounts of energy. The anode, the other electrode, is usually made from graphite. Graphite is used because it can accommodate the lithium ions during the charging process. When the battery charges, lithium ions move from the cathode to the anode. This movement is driven by the electrical energy supplied during charging. During discharge, when the battery is powering the car, the lithium ions flow back to the cathode. This reverse movement releases the stored energy, powering the vehicle's electric motor. This movement of ions creates an electrical current. The current generated is what ultimately powers the electric vehicle, making it a clean and efficient mode of transportation. The amount of energy a battery can store depends on the materials used and the size of the electrodes. Advanced materials and larger electrodes can significantly enhance the battery's capacity and performance. Once the individual battery cells are produced, they are assembled into larger units called modules. These modules are then combined to form the complete battery pack. The battery pack is the powerhouse of the electric car. The modules are connected in series and parallel to achieve the desired voltage and capacity. The voltage determines the power output of the battery. The capacity determines how far the car can travel on a single charge. The battery pack is equipped with a battery management system, or BMS. The BMS monitors the voltage and temperature of each cell. It also ensures that the cells are charged and discharged safely and efficiently. The battery pack is typically located under the floor of the electric car. This placement helps to lower the car's center of gravity, improving its handling and stability. Ensuring excellence. Quality control and testing. Quality control is paramount in the production of electric car batteries. These batteries must be able to withstand demanding operating conditions. They undergo rigorous testing to ensure their safety and performance. Throughout the manufacturing process, the batteries are inspected for any defects. The cells are tested for their electrical properties. The modules and packs are subjected to vibration and impact tests. The batteries are also tested under extreme temperatures to simulate real-world conditions. They are charged and discharged thousands of times to assess their lifespan. Only batteries that meet the highest standards are used in electric cars. These comprehensive quality control measures are essential for building consumer confidence in electric vehicles. They help to ensure that electric cars are reliable and safe to drive. The advantages of electric car batteries. Electric car batteries offer numerous advantages over traditional gasoline engines. One of the most significant benefits is their efficiency. They are more energy efficient, producing zero tailpipe emissions. This means that electric cars do not contribute to air pollution in the same way that gasoline-powered vehicles do. This makes them a cleaner alternative to fossil fuels, which are a major source of greenhouse gases and other pollutants. Electric cars are also quieter than gasoline-powered vehicles, reducing noise pollution. This can lead to quieter, more peaceful urban environments. They require less maintenance, as they have fewer moving parts. For example, electric cars do not need oil changes, which are a regular requirement for gasoline engines. This can result in lower operating costs over the lifetime of the vehicle. Owners can save money on both routine maintenance and unexpected repairs. The increasing adoption of electric cars is driving innovation in battery technology. Researchers are constantly working to improve battery performance and longevity. We are witnessing the development of batteries with higher energy densities. These advancements allow electric cars to store more energy and travel longer distances. This means that electric cars can travel farther on a single charge, making them more practical for long-distance travel. Governments and automakers are investing heavily in electric vehicle infrastructure. This includes building more charging stations and improving the electric grid. The expansion of charging stations is crucial for the widespread adoption of electric vehicles. It ensures that drivers have convenient access to charging points. As the technology continues to advance, electric cars are becoming an increasingly attractive option for consumers. They offer a combination of environmental benefits, cost savings, and convenience that is hard to beat. The challenges of electric car batteries. Despite the many advantages, electric car batteries also present some significant challenges that need to be addressed for the technology to become more widespread and efficient. One of the main challenges is the cost. Electric car batteries are expensive to produce, which can make electric vehicles more expensive to purchase than gasoline-powered cars. The high cost is primarily due to the materials used in the batteries, such as lithium, cobalt, and nickel, which are not only costly, but also require complex and energy-intensive extraction processes. Another challenge is the range of electric cars. While the range of electric cars is increasing, it is still limited compared to gasoline-powered vehicles. This can lead to range anxiety, especially for long journeys. Range anxiety is a significant concern for many potential electric car buyers, as it involves the fear of running out of battery power before reaching a charging station. This can be particularly inconvenient for those who frequently travel long distances or live in areas with limited charging infrastructure. The charging time of electric car batteries is another consideration. While charging times are decreasing, it still takes longer to charge an electric car than it does to fill up a gasoline tank. This can be inconvenient for some drivers, especially those who are used to the quick refueling times of traditional gasoline vehicles. Additionally, the availability of fast charging stations is still limited in many areas, which can further exacerbate the inconvenience. The environmental impact of battery production is also a concern. The extraction and processing of raw materials can have negative consequences for the environment. Mining for materials like lithium and cobalt can lead to habitat destruction, water pollution, and other environmental issues. It is important to ensure that these processes are conducted sustainably. Efforts are being made to develop more eco-friendly battery technologies and recycling methods to mitigate these impacts. The future of electric car batteries. The future of electric car batteries is bright. Researchers are constantly working to improve battery technology. They are developing new materials and designs to enhance battery performance. Solid-state batteries are one of the most promising areas of research. These batteries use solid electrolytes instead of liquid ones. This could lead to safer, more energy-dense, and faster-charging batteries. Another area of focus is the development of sustainable battery recycling technologies. Recycling batteries can help to reduce the environmental impact of electric car production. It can also recover valuable materials for reuse. As battery technology continues to advance, we can expect to see electric cars with longer ranges, faster charging times, and lower costs. These advancements will further accelerate the adoption of electric vehicles worldwide. A powerful revolution. Electric car batteries are at the forefront of a transportation revolution. They are powering a shift towards cleaner, more sustainable transportation systems. Understanding how these batteries are made is essential for appreciating the complexity and potential of this technology. From the raw materials to the intricate manufacturing processes, electric car batteries represent a triumph of engineering and innovation. While challenges remain, the future of electric car batteries is filled with promise. As we move towards a future powered by renewable energy, electric car batteries will play a pivotal role. They will continue to evolve, becoming more efficient, affordable, and sustainable. The journey towards a cleaner, greener future is being fueled, in part, by the remarkable technology behind electric car batteries. If you like this video, don't forget to hit the like button and subscribe for more exciting content, updates, and new uploads from Manufactour straight to your feed.